Hey everybody, welcome to this discussion on the noise assignment for E314 at Cal Poly. My name's RJ and I'm going to be going over some clarifications for the homework that I just created. So let's share the screen. All right. Here is the exercise. As you know, it's due tonight. This was pretty straightforward. I think everybody got this part. Actually, these first three questions were all pretty straightforward. I haven't had any questions on those. Just as a note for number 4, instead of evaluating the Q function for each of your 3 cases, this is supposed to say plot the Q function. But if you've already done the assignment and you just evaluate it at some point that you specified, that's fine as well. And then for number 5, this was actually in the example code, the example MATLAB script that I gave you guys. I'll go over it, but basically just change the parameters to a mean of 5, standard deviation of 2, and sample size of 100. So that was pretty straightforward. And then for number 6, we want to generate 1,000 samples for 0 and 1,000 samples for 1. And we want to show the scatter plot for these. And these samples are follow a Gaussian distribution with a variance of 0.1. So basically you'll have, right, your 0 samples will be centered around 0, but they will be distributed normally. And your 1 samples, same idea, they'll be distributed like about this mean of 1. It was the idea of there with a variance of 0.1. For number 7, this is where a lot of people were confused. This is actually supposed to be a continuation from number 6. So you're supposed to have the decision boundary at 0.5. So you basically want to bisect these two. And you might find that the true positives and the true negatives are at 100% just because of that small variance that I used. And I think for the future, I'm going to be changing this variance so that we have some more interesting results. And then for number 8, this is also kind of a continuation off of number 6. So you move the decision boundary to 0.4 and 0.6. And then you just do the same problem as number 7. Basically, you present the confusion matrix. And then I think these two were fairly straightforward as well. I'll just go ahead and talk more about the idea of the confusion matrix. So like I said before, we have these random variables, right? So the samples of 1s, I'll just draw them in as an X maybe. So here's our, say, 10 samples or so. All right, let's say we have some outliers down here or something, which you might not see with the small variance that I gave, but in a real world problem, these classification problems will have samples that go into the other regions, which is why there's a whole field of this study. So here are the 0 samples, we'll just draw them in as circles. So the idea here is we have this decision boundary, say it's at 0.5, right? So these X's up here, this region, these are all correctly classified as 1, right? So this will be referred to as a true positive. And all of these O's, all the O's that are below the decision boundary are correctly classified as well. So these are true negatives, right? So then any X's that are appearing down here, right? So these are going to be false, false negatives, because they are incorrectly classified as a 0, right? And then right here, really close to the decision boundary, we've got this one false positive. And that's just kind of the basic idea. Another way to look at this is through the histograms. So these are, this is a scatter plot representation of this problem. Another way to picture this is if we have the distributions, right? So let's say, well, okay, yeah, the axis is a little weird here. So say we have like a normal distribution at 0, and then we have another normal distribution at 1. Right, so this region, or actually, so we need to define the decision boundary. So here we have it at 0.5 again. So anything in this region here, true positive. Well, the coloring is all messed up, but you get the idea, right? So you have your true positives. These are correctly classified because they are on the correct side of the decision boundary. And then here we have the true negatives to the left of the decision boundary that are actually 0. And this lower tail here, this lower red tail that cuts through the decision boundary, that's where we're going to have our false negatives. And then likewise, we're going to have our false positives, the black line to the right of the purple decision boundary. And hopefully that kind of clears things up a little bit. I mentioned in a previous announcement, an easy way to do that is say we have our ones, so this is going to be an array of 1,000 samples, right? So it's just going to be like 1 by 1,000. And these are just going to be our samples of normally distributed values of ones. So one way we could do this, so in MATLAB, we can return Boolean values by checking if the ones are, say, greater than the threshold. Right, so if you just try running this right here, it's going to be a bunch of 1s and 0s. So it's going to be 1 if true, and then 0 if false. Well, this might be a little confusing. So basically, it locates anywhere where these samples are above the threshold. And then if we do a find ones greater than threshold, this will return the indices of each occurrence. Right? Each occurrence where this one's greater than threshold is true. And then if we grab the length of this find one's greater than threshold, then this gives us the number of occurrences for this statement, one's greater than threshold. So that gives us the number of occurrences. One way we could get the rate of occurrences, right? So we just kind of divide. So let's say this is, so when the ones are greater than the threshold, these are true positives. So if we wanted the rate, we call that TPR. We divide TP divided by the length of our array that we're checking over, which will just be the number of samples basically. And this will give you the rate, the true positive rate, which should go into, I mean, either one of these can go, the true positive count or the true positive rate can go into the confusion matrix. I've seen both. But yeah, I hope that clears things up. I'll catch you guys in the next video.